Hi, so this video, as the name suggests, is about naming hydrocarbons, okay? So you should have a grasp now on the different formula that we represent hydrocarbons and organic molecules with, and this is how you would go about naming them. So the first thing you do when looking at naming a hydrocarbon is looking at the number of carbon atoms that are there, okay? And as these get to more complex examples, this will turn into the number of carbon atoms in the longest carbon chain. So this gives us the start of the name, the prefix or the stem. So in practice, if your hydrocarbon only contains one carbon atom, the start of the name will be meth. Whereas if it contains two, it will be eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, and 8 oct. Okay? So putting that into practice, we have a hydrocarbon up here with 1, 2, 3, 4, 5, 6 carbon atoms. Therefore, the start of its name will be hex. Okay? Pretty simple, yeah? And then a skeletal formula example here, with 1, 2, 3 carbon atoms, will start with prop. So that's how we get the first part of the name, by the number of carbon atoms in our molecule. The second or end part of the name is dependent on the functional group or the type of bonding in our organic molecule or hydrocarbon. Okay? This gives us the suffix, or the second part of the name. And in practice, looking at the two that you would have covered already at this part in the module, alkanes and alkenes. So alkanes are molecules with only single bonds, and the end is ane. And then alkenes contain at least one double bond. These will end in the suffix ene. Okay? A couple of examples here. These are the two examples from the page before. They only contain single bonds, and therefore the ending of their names will be ane, A-N-E. Okay? And then, obviously, if there is a double bond, like we see here, these molecules will end in ene, because they're alkenes, okay? So it's whether the molecule is an alkane, ends in ane, or alkene, ending in ene. So we're going to do a couple of examples now. We've got a skeletal formula alkane here, and we're just going to work out exactly what name that it has, so you'll be able to name it yourself. Okay? So, this example here has 1, 2, 3, 4, 5 carbon atoms. Okay, so the start of the name will be pent, because it has 5 carbon atoms. And we can see, due to the lack of double bonds, only single bonds in this structure, that it's an alkane, and therefore it will end in ane. So this molecule here is pentane. Pentane, nice and simple, okay? We have a displayed formula, example here, with 1, 2, 3, 4, 5, 6 carbon atoms. Again, only single bonds, so we know it ends in ane. So we have hex for 6 carbon atoms, ane for alkane, hexane being the name of this hydrocarbon. Okay? Okay, on the contrary, alkenes. So we have the same naming with the number of carbon atoms, that's always what we start with. However, the suffix, the ending, will be different because it will be for an alkene. The ending will be ene. We have an example here with 4 carbon atoms. 4 carbon atoms mean it will start but. And we have a double bond, so we know it's an alkene. Okay? Now the thing about alkenes is the double bond can be located in different places on the hydrocarbon. If we just called this molecule butene, yes, we would know it is an alkene, but we do not know the location of this double bond. It could be on the end of the molecule, it could be in the middle. Therefore, when naming this molecule, we will include a number to symbolize where the double bond is located, and in this case it starts at carbon 2. So this molecule here is but2-ene, because it's buttes with 4 carbon atoms, 2 because that's the location of the double bond, ene. Okay? And we'll do it again with this example. Now what we notice with this example, instead of naming the carbon atoms 1, 2, 3, 4, 5, 6, what we do is we start naming the carbon atoms from the side of the molecule that is closest to the functional group, and in this case it's that double bond. Okay, so on this example, this side of the molecule is carbon 1, and we have carbon 2, 3, 4, 5 and 6, but we start here because this is closer to the functional group, and again we need to symbolise where the double bond is, okay, by including that 2, because it's on carbon 2. So, from the start with this molecule, first of all, we know it has 6 carbon atoms, okay? Because it has 6 carbon atoms, we know it starts with hex. Yes, it does have a double bond, so it ends in ene for an alkene, and that double bond is located on carbon 2, starts on carbon 2. And it's obviously with carbon 3, but it starts on carbon 2. Therefore, this molecule is hex 2-ene. Okay? We've got another example that you can try now. So, remember the rules for naming that we've gone through? First, looking at the number of carbon atoms that a molecule contains, and then the functional group, or the bonding that is going on in the molecule, and then possibly the position of any double bonds in the molecule. Okay, so just pause the video now and then unpause when you're ready for the answer. Okay, so I'm going to go through the answer now. This molecule is named hept3-ene. So well done if you got that right, but I'm going to go through it if you didn't, so don't worry. This molecule has 7 carbon atoms, and that's where we get the stem of hept. Okay? It contains a double bond, and therefore ends in ene. And the location of that double bond, if we count the carbon atoms from the end that is closest to the functional group, in this case that double bond, 1, 2, 3, the double bond starts on carbon 3. Okay? Therefore we have hept3-ene. I hope that makes sense. Thank you for watching this video, and we'll see you at the next one.